practice two exercises in which we have to apply the product and the quotient rules. These are the exercises we had yesterday in our classwork. So, as you know, this is the rule that we apply when we have a product. We have a function which is the result of multiplying two other functions, a and b. So to find the derivative of f, what we find is a prima times b and then plus b prima times a. And doing that, we are going to say that in this exercise, all this is going to be a. So a is equals 3/5 of a fifth root of x, and b, it's going to be the other part, that is 2x to the power of 5 plus 3x to the power of 3 minus 2x. Having said this, we are going to find the derivative of each of these two ones to find a prima and b prima. However, maybe it's not very simple to find the derivative of this function if it is in root. So we're going to, first of all, write it in terms of an exponent. That is 3 over 5, x to the power of 1 over 5. And then once we have it like that, we can find the derivative. However, I know that many of you are going to make the mistake to think that in this stage we have already derivated, and that's not the case. I want you to be very clear about that part. This is not the derivative of a. We haven't done anything so far, and this or this are exactly the same. They are equivalent. But once we have it like that, we can find a prima. And finally, a prima would be 3 over 5. This 1 over 5, it's going to go like 1 over 5. And then 1 over 5 minus 1 is minus 4 over 5. This is already the derivative of a, what we call a prima. However, we can simplify it so that we can apply it in the rule, in the general rule later. This is just a matter of multiplying two fractions. The numerator times the numerator is 3, and then the denominator's multiplication is 25. And then what we have is x to the power of minus 4 over 5. This is already the derivative. However, as I have told you, in mathematics, we are not supposed to leave our answers with negative exponents or fractions. So we have to eliminate both. How do we do that? Well, I'm going to do it like a prima would be equals to what? 3 over 25. And now my x, which is negative in the exponent, is going to be positive now. That is 4 over 5. And remember what I have told you. When we have a fraction in the exponent, the numerator indicates the power. On the other hand, the denominator indicates the root. So what we have is 3, 25, and then we have fifth root of x to the power of 4. This is what we're going to use in our formula. We're almost done. If you found this answer, I think you can have half of the point, even though b prima is incorrect. However, I don't think b prima could be incorrect because it's much more simpler. Like b prima would be equals to what? 10x to the power of 4 plus 9x to the power of 2 minus 2. This is it. So applying the rule, what we have is that the derivative of f would be equals to a prima times b. That means 3, 25, fifth root of x to the power of 4 times b, which is 2x to the power of 5 plus 3x to the power of 3 minus 2x then plus we have b prima, which is b prima times a, right? And this is a. This is a, so I think it's convenient to put a first. I'm putting b prima times a, but I'm going to put a first because here we have a number. 3 over 5, fifth root of x, and then times b prima, what is 10x to the power of 4 plus 9x to the power of 2 minus 2.
And
this is it.
And
This,
if you put b prima first?
no, well, if you put b prima first, that is, if you put this parenthesis first and then this other one, that would be the same. However, it's not simplified. What I mean is that if, for example, in an exercise, if I give you, if the answer has to be something like 2x and you write x times 2, as you see, it's the same. However, this is not simplified. That is what I mean when I say that you have to put the number first.